Hello everyone. I'm here to talk a little bit about about the EmuFlight versions 2.16, well 2.16 up to 2.18, and kind of just what's gone on during that time. Let me just refer back to the commit history real quick. So this one is right here. So in version 2.15, not 2.15, 2.16, we've added, or I've added, a bit of code that, yeah, there we go, 2.16. I've updated the Kalman filter. Yeah, basically just updated it so it's more in line with version 2.09b versus the 2.09a version of the Kalman filter. The 2.09a version we've just found wasn't as good, so I've updated it to be the 2.09b version of the Kalman filter. Got that. Something else that I've done is I've actually changed the horizon code. The horizon code's completely completely redone according to the commit that NFE made in his own Betaflight repository a year or two ago. So I added that stuff to here. I've tested it. Horizon mode works. No issues whatsoever with that. So there's new horizon mode code for those interested. Yeah, so those are two things. Something else, I'm not sure I can find it, but I made it so that yeah, right here. So it used to be that every 400 times a second the attitude of your craft would be updated. That was originally 200 times a second, and I've updated it to 1,000. It does use more CPU load when your accelerometer is enabled, but this is just a test to see if updating it more is better. The Helio flight controllers by default update it this quickly. I'm doing it on these craft. These smaller craft have done it with no real issues. But I haven't been pushing the higher update rates as of super recently. So there's some behind the scenes stuff. As you can see, I made dshot 600, the default protocol, and of course your Helio spring. Not your Helio spring, your Strix F10. Of course that one's dshot 1200 to support the 32K that it's doing. But I'm not really sure how I feel about that. So this latest one, I've actually done something a bit different. I've added basically a complimentary filter to combine the accelerometer data and the gyro data. Now to turn that on, it is right there, combine gyro and ACC. This bit of code. So yeah, set combine gyro and ACC or accelerometer equals on. You do that, and in the PID loop for your pitch and roll, not your yaw, because it's a bit harder to determine your heading on yaw using the accelerometer just because of gravity and other things. But for your pitch and roll, I might even just try experimenting with turning it on in yaw. But for pitch and roll, at least now, this piece of code combines your gyro and accelerometer data. The data is, at least at this time, it's 5% accelerometer and 95% gyro. That just came from brute force testing. Found if I went much lower, if I went and used much more accelerometer data, I'd run into noise and I feel like much less than this, and it's not going to really do anything. So this is something that I think would be fun to test. Maybe it's not worth doing, and maybe the accelerometer is just too noisy. But I think that some of this noise can be overcome if we start doing things a bit differently. So now I'm going to get into some talk that doesn't have to do with these new versions. Because these new versions, there's not a ton going on, just updating the Kalman filter a little bit, updating horizon mode, and then setting the default to dshot 600, and now just combining some gyro and accelerometer data. It's something that I've been playing with. What I've been playing with recently. There we go. As you can see, my gyro hardware is set to 1 kilohertz sampling. Now, if you haven't seen, we've been recently discussing some stuff like this, but I know a lot of you testers and other users, you came from Helio, and a lot of you Helio users, you came from EmuFlight, and for a lot of you, there's just a history of using 32 kilohertz or 16K, but setting that gyro to 32 kilohertz mode, and believing that 32 kilohertz was better and is the way to go. Now, whether or not 32 kilohertz is better is up in the air. What I can say is, regardless of whatever data you can throw at me or whatever you can say, 32 kilohertz does use a whole lot more computer, a lot more CPU, which is obvious because you're doing things 32 times as fast. And so it's going to be using more computer, more RAM. Another thing to consider is the gyros are noisier at those higher frequencies. Just a quick example is a while ago I was trying to get my craft to fly well in running 16K, but putting the gyro instead of it 1 kilohertz or even normal, I was going to experimental, which it essentially turns the internal low pass filter off. It sets that filter to 8 kilohertz for the internal gyro filter that's built into your gyro. And I could just never get things to fly well. I always had to keep it on normal. But even then, just from what I've played around with, I'm starting to think that 1 kilohertz sampling might be all that we need. There is more. Some of the downsides to 1K is obviously the PID loop runs slower, so it won't respond as quickly as 32 samples. If there is a change, it could take, in a sense, 32 times as long before that change makes it to the PID loop. But we're talking very, very short time intervals when we start talking about that. There's not a whole lot of extra latency. And if you talk about the extra filtering latency that comes from the internal gyro filter, yes, at 1 kilohertz, the built-in gyro filter does filter more. Now, to compensate for that, we can just run our own software filters at higher frequencies, so we're filtering less with our software and more with just the built-in gyro. That might be one way of doing things. Something else kind of along those lines is the IMUF filter. At higher frequencies, it filters less. So the same settings on a higher frequency will be filtering less, and at a lower frequency, it will be filtering more. Now, that means if you've got your quad nicely tuned at 32K or even 16K, you're going to have to change your settings to get it to fly the same at 1K. So what I'm saying is I would like you guys to try out filtering at 1 kilohertz and try out flying with the mode 1 kilohertz sampling enabled, because just running like 32K, you know, you're sampling the gyro at 32K, running it at 1K or even 8K 1K, it's not really going to quite be the same as 1K 1K, because the internal gyro filters at 1K 1K were made specifically to be run at 1K 1K, because you do run into things where any frequency higher, if you're sampling at 1K, any noise higher than 500 hertz, you can't accurately see them in your system just because of how you've set it up. Because you're sampling at 1K, you can only see noise up to 500K. Well, not 500K, up to 500 hertz. And so anything higher than that, it'll still enter your gyro, but it ends up as what's called aliasing, and you get lower frequency noise appearing that actually isn't lower frequency noise. It's actually higher than 500 hertz, but it's showing up as lower than that. And so the digital gyro low-pass filters, or the filters built into the physical gyro chip, they're made so that at 32 kilohertz they filter enough to remove that aliasing, so that noise that shows up on low frequencies but it's actually a higher frequency, that doesn't appear. Same at 8 kilohertz, and then at 1 kilohertz they filter again a bit more though to get rid of that aliasing. And so if you're running 32K1, then my assumption, I haven't tested this a ton and I could be wrong, but my assumption is that you would run into more aliasing and get more ghost low frequency noise, where it's actually noise that's higher that's just leaking through. Now that's why I'm thinking that you'd want to turn your gyro to 1 kilohertz sampling, turn the mode to gyro hardware low pass filter is that 1 kilohertz sampling, so that when you're doing 1 kilohertz you're actually getting the true filtered data, and it, that anti-aliasing, they call these filters anti-aliasing filters as well, so you get that data without aliasing at 1 kilohertz. And that's why these gyro manufacturers have set these internal filters, is you do get aliasing, and these filters can help remove that aliasing. And so I would like to see some more testing of 1K 1K. If you are running the combined gyro and accelerometer, if you're running things at 1K 1K, then you're running both the gyro and the accelerometer both at 1 kilohertz. If you're running it at different values, then you'll be running the accelerometer slower. But yeah, so there's just a few things I'm testing now. I'd love to hear your feedback on it. Something I've been thinking about recently is just getting EmuFlight to be one consistent PID loop and gyro loop rate, and making that default across the board. There's a few things that would be nice about that. For example, the IMUF filter, it changes exactly how strong it's filtering based on your gyro loop rate. And so with people running different gyro loop rates, the filtering is going to be different. So someone that's running 32K and then they switch down to 8K, the IMUF filter is suddenly going to be filtering more at 8K than it was at 32K. So if we could just have that all one PID loop rate, we wouldn't have to worry about that and how that changes. Some of the other internal code could be cleaned up a bit, which would be nice. But I think from a user standpoint, it would be nice to have that. And from everything I've seen and read and thought about, 1 kilohertz is probably enough of a sampling rate, and 1 kilohertz is the least noisy. Maybe we don't get as much data, you definitely don't, but I think it might be enough. And anyone that's wary of that, I'd just say that you should test it. Just forget any of the science or any of the logic or reasoning you have against 1 kilohertz and just give it a try. Just fly it mess with your filters a bit because they might need a bit of changing, but fly it, see how it goes, and you might really end up liking it. I've been surprised. I've been a 32 kilohertz fan since the early race flight days, and now I'm thinking I might be a 1 kilohertz guy. But yeah, I'd love to see your thoughts on that, and have a good one. Enjoyed trying the gyro and accelerometer combined. It's pretty cool. Anyways, have a good one, everyone.